Okay, this is homework number 12, part 3, and I'm answering the question, where did you get those numbers? So recall, we've got our example. Steve judges that it's more likely for men over 65 to have a heart attack than for men over 18 to have a heart attack. So we're essentially doing a back of the envelope calculation where we make up the numbers because it doesn't really matter what the numbers are. The point is that a conjunction won't be more probable than either conjunct on its own. And we're just illustrating that with some numbers. So where'd the numbers come from? Now, assuming that we're only considering the population of adult-aged men, let's say, I'm making stuff up, I think it's roughly accurate, but let's say that out of the entire population of adult men, 20% are 65 plus. So if we let these 100 dots be adult men, then the blue ones, that's 20% of these dots, are 65 plus, and the other 80 dots, 80%, under 65. Now, let's say, pulling these numbers out of nowhere, that the probability for a man who's not in the 65 plus age range to have a heart attack is 5%. So we're looking at the 80 dots here. What's the probability? Let's say it's 5%. What is 5% of 80? Well, if you think, what's 10% of 80? 8, half of that, 4. So I randomly just picked 4 dots from this category. This is what it would look like for 5% of these people to have a heart attack. And let's say that the probability that a man 65 or older has a heart attack is 20%. It makes sense it would be higher. These numbers probably aren't way off, but again, I'm making them up. So here's the 65 plus, and what would it mean to say 20% of 20 people have a heart attack? Well, 10% of 20 would be 2, so double it, 4. So 4 people in this randomly picked here are likely to have a heart attack. Okay, so now, what is the probability that a man of any age has a heart attack? Well, here's all of the men of all ages, right? So we'll just count them. 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 100 men, where these are the relevant ratios of under and over 65, will have a heart attack. So that's where the 8 out of 10 came from. Now, what's the probability that a man is both 65 and has a heart attack? Again, we're just looking at the dots. 1, 2, 3, 4. 4%. And the point is that the probability that a man is both in this section and has a heart attack is smaller than the probability that anyone has a heart attack of any age range. Now, why would the person who reads this think that, and this is, an oversimplified case, but why would a person potentially hear this and judge that it's more likely for someone over 65 to have a heart attack than for someone over 18 to have a heart attack, when the over 18 includes everybody, including these 4 dots, whereas over 65 only includes these people? Well, because we have stereotypes, right? So we immediately went like, oh, people over 65 more likely to have heart attacks than under 65. However, the wording is that over 18, not just, and not under 65. But at any rate, the answer to the question is essentially that I pulled these numbers out of nowhere to illustrate that being in the blue area and have possibility of being a red dot is lower than the possibility of being in either area and being a red dot. Make sense? Hopefully. Feel free to follow up if you have a further question.